This is how to convert from any units to any other units, specifically when we're dealing with multidimensional units. So for example, to convert from liters to cubic meters and back and forth, we have multiple dimensions because this is meters cubed, so you have 3 dimensions. First, you can draw out your diagram right here of the larger units, which would be cubic meter. So this whole box right here is 1 cubic meter, which is 1 meter in every dimension. Then inside of that, we superimpose our smaller units, which would be 1 liter. So 1 liter will be 10 centimeters in each dimension. 1 cubic meter will be 100 centimeters in each dimension. Notice in these cases here, when we're dealing with a unit greater than 1, centimeters cubed is different than cubic centimeters. If you're just dealing with 1, and I just wrote that right here, if you're just dealing with the number 1, then 1 cubic centimeter is the same thing as 1 centimeter cubed. But when we're dealing with numbers greater than 1, as you can see, this cubic meter, it is 100 centimeters that direction, back left and right, 100 centimeters deep, 100 centimeters tall. That is 100 centimeters, quantity cubed. If we carry the 3 through, or we distribute that 3 to the 100 and distribute it to the centimeters, now we end up with 1 million cubic centimeters. Earlier I said that this doesn't work for any units that are greater than 1, but it's actually for any units other than 1. So for example, if we're dealing with 1.5 or 10, or even something less than 1. So if we're dealing with, say, 0.3 centimeters cubed versus 0.3 cubic centimeters, those are 2 different volumes. I looked into this a while back to see if any experts had any opinions on this, on the difference between a centimeter cubed and a cubic centimeter. And some people said that it is preferable to speak in terms of cubic centimeters. That way there is no confusion. Now in this case right here, I wrote 100 centimeters quantity cubed with those parentheses. But if I didn't have those parentheses there, it would simply be 100 centimeter and then a cubed. So it would look like 100 cubic centimeters, which means I would need to take the cube root of that 100 to find out what the dimensions are, or to find out what each dimension is going across, deep, and up on that cube. The same idea here for the 1 liter, which is 10 centimeters quantity cubed. Distribute your 3 through, and you'll have 1,000 cubic centimeters. And again, that's because we have 10 centimeters on each dimension. 10 centimeters across, 10 centimeters deep, 10 centimeters up. The key on this is don't think in multi-dimensional units. Turn everything into linear or a single dimension, and I'll show what I mean. So again, I can't overemphasize this enough. Get rid of your exponents, make everything linear. So this cubic centimeter is 100 centimeters in each dimension. So let's simply take 100 centimeters in one dimension, divide that by 10 centimeters, because 1 liter is 10 centimeters in each dimension. 100 divided by 10 equals 10. So now we know we have 10 liters going across, 10 liters deep, 10 liters up. That's 10 times 10 times 10, 10 to the third, which is 1,000. That means that 1,000 liters will fit in, or 1,000 of those little tiny cubes that are liters will fit inside of 1 cubic meter. Your ratio can look like this: 1,000 liters per cubic meter. With fractions, you can multiply or divide the top or bottom by whatever you want, but you have to do the same to both sides. And by the way, that only works for multiplication and division. It doesn't work for addition and subtraction. You can play around with some numbers on that to find out how that works. But anyways, so this 1,000, we can divide the numerator and the denominator by 1,000, as I showed right here. 1,000 divided by 1,000 is 1. Then right here, 1 cubic meter divided by 1,000 becomes 0.001 cubic meter. Thus, 1,000 liters per cubic meter, or 0.001 cubic meters to 1 liter. And you can set this up as a fraction or as an equivalence where you have an equal sign with liter on one side and the cubic meter on the other. Next up, on that page, I went from cubic meters to liters. Now I'm going to go from liter to cubic meter. Again, I can't overemphasize this enough. Think in terms of linear and not multidimensional. So just take 10 centimeters, because that's the length of one dimension, divided by 100. 10 centimeters across is a liter. 100 centimeters across is a cubic meter, or sorry, just a meter. That gives you 0.1. Therefore, we know that this 1 liter right here, it is 0.1 meters to the right, or across, 0.1 meters deep, 0.1 meters up. That is 0.1 in all dimensions. I might even write that right here. There we go. 0.1 dimensions, 0.1 meters in all dimensions. So you take 0.1 cubed, gives you 0.001. And again, you can do a fraction, 1 liter per 0.001 cubic meters, or set it up as an equivalence with an equal sign. Same difference, as we used to say as kids. And the last way I got here to show how to do these conversions, just cube everything from the beginning. If you're feeling a little bit more advanced, 1 cubic meter is 100 centimeters in each dimension. So you got 100 times 100 times 100. So that is 1 million cubic centimeters divided by a liter, which is 10 centimeters in each dimension. 10 times 10 times 10, so that's 1,000. Take a million divided by 1,000, you end up with 1,000. Notice here the cubic centimeters will cancel. Cubic centimeter divided by cubic centimeter, and so it just leaves you as a 1 to 1,000 ratio. If you want to make this appear a little more confusing, you can put exponents all over the place. Turn that million cubic centimeters into 10 to the 6 cubic centimeters. The 1,000 cubic centimeters will become 10 to the 3rd cubic centimeters. So now we have a 10 to the 6, centimeters to the 3rd, 10 to the 3rd, centimeters to the 3rd, and you get the same answer of 10 to the 3rd. Just a little more confusing. In that example of volume I just showed, we have 10 centimeters evenly going into 100 centimeters. But what about when the smaller number here does not evenly go into the larger number? And I'm going to show that here. So again, can't overemphasize this enough. Get rid of your dimensions. So I have my box here that's 1 inch squared, and I have inside of this 1 inch squared, 1 centimeter squared. Let's get rid of the dimensions, get rid of those squared, and just make everything linear. So 1 inch going across right here is 2.54 centimeters from here to there. You can do a ratio here, 1 inch per 2.54 centimeters. With a fraction, do whatever you want to the denominator or numerator. Just do the same to both. Let's divide both sides by 2.54. So we just end up with the inverse. We end up with 0.39 inches per 1 centimeter. I drew this out here on the diagram. So we have 1 centimeter right here from there to there, and then 2.54 centimeters going all the way across, and then going up from here to here is 0.39 inches. So this way I'm showing both units. I've got my inch here, my inch there, centimeter here, centimeter there. So what we can do here, again, since we're getting rid of our exponents, let's convert from square centimeters to square inches. 1 centimeter in one direction is going to be 0.39 inches. So we have 0.39 inches up, 0.39 inches across. That's 0.39 squared. I'm carrying it out to some extra decimal places there though. So we end up with 0.15 square inches. Do the same thing from inches to centimeters. Turn inches into centimeters. We end up with 2.54 centimeters going all the way across for one side of your square inch. Go ahead and square that 2.54. Now we got 6.45 square centimeters. So I think knowing this gives a nice feeling of power or independence. That if you know how to do this to convert from one area to another or one volume to another, then you won't be dependent on having to use apps to do that for you. Of course, the apps are a lot quicker and easier, but it's still nice to know that we can do it on our own.